All right, so our last section in 7.6, chapter 7, sorry, is 7.6, and it's on solving trig equations analytically. Okay, analytically means with algebra. Okay, it means not graphically, but we're going to use algebra. Right, so the techniques we're going to practice, but you already know them. Okay, some techniques we're going to use are factor. Okay, we did some factoring in some of the homework problems. You pull out what they have in common. Writing everything in terms of one trig function. Right, so if you have a problem where there's different trig functions, like this one, you have sines and cosines, we'd rather have just one trig function. Okay? And the last thing that's going to help us is the quadratic formula. Right, so we have to recognize, first of all, when we use it. Okay, you use the quadratic formula when you have a quadratic equation. Okay, this is probably what you're used to a quadratic equation looking like. Okay, something squared, then you have just the something, and then at the end you have a constant. Okay, that's a quadratic equation. Well, it doesn't just have to be an x. This is a quadratic equation too. Sine squared plus 3 sine x plus 2 equals 0. In fact, the way I would solve this one is exactly the way I would solve the one above it. Okay. A is 1, B is 3, C is 2. But the key is you have to recognize this as a quadratic equation. Something squared, the something, and then just a constant. In this top equation, when you use the quadratic equation, what are you solving for? Yeah, you're solving for x. You're solving for what's right there. So in this bottom equation, what do you think you're solving for? Sine what? Sine, right. You're solving for sine x. Okay, when we use the quadratic formula, it's not going to give us x. It's going to give us sine x. So we might have to think what that last step would be to get rid of sine. And we did that before, inverse sine. Okay? So in general, any equation that looks like this. You have a, it's your first coefficient. And then you have something. And that thing has an exponent. And you have b. You have the same something, another exponent, and then a constant. That's a quadratic type equation. And notice the way I wrote the exponent. I just didn't write a 2 here and a 1 here. Quadratic equations happen anytime that the first exponent is double the second. It could be 4 and 2. N could be 3, so 6 and 3. N could be 5. So you'd have 10 and 5. Anything like that is a quadratic equation. And you're always solving for what's right there. Most of the time for us, it's going to be either sine or cosine. And the constant, that's c in the quadratic formula. So we're not always going to have to use quadratic formula. We might be able to factor, and then we can avoid it. But if we can't factor, then we'll use quadratic formula. All right. So for this problem, they want us to find all solutions just between 0 and 2 pi. Okay. You guys remember when we put like plus 2 pi k or plus pi k on the end of our answers? We're not doing that in this section. They want you to find all the answers, but they're giving you bounds to be between. Okay? 0 and 2 pi. Now, this is almost a quadratic type equation, but what's wrong with it?
Different symbols like S.
Yeah, we have different trig functions. Okay? We have some sines and we have some cosines. We need to get just one trig function. Okay, so my hint is going to be get rid of this. Okay? And the way to do it is something we've learned before. Sine squared plus cosine squared equals 1. Okay? That's a Pythagorean identity. If I rewrote this identity and got cosine squared by itself, anybody tell me what cosine squared would equal?
Negative sine squared.
1 minus what?
1 minus
Sine squared. Yes, just bringing sine squared to the other side. So I'm going to replace cosine squared with 1 minus sine squared. And make sure you put it in parentheses when you replace it. Okay, I think you'll see why in a second. So you're going to have 2, and now replace cosine squared. 1 minus sine squared. Okay, keep everything else the same. Okay, why did I put that in parentheses? Right, because now I'm going to distribute. Okay, and I can distribute and combine like terms at the same time. Pat, what's 2 times negative sine squared?
Negative 2 sine squared.
Yeah, it's just negative 2 sine squared. Don't worry, I didn't forget about 2 times 1. I'm going to come back to that. Plus sine. Okay, and Derek, what's 2 times 1? 2? Plus 1 more? 3. Okay, so I did 2 times 1 is 2. Plus 1 is 3, so I combine my like terms at the same time. Now I have a quadratic type equation. Something squared, something, and the 3. Any questions up to that step? All right, so let's see. This one I think we can factor. Okay, we could use the quadratic formula, but we're going to try to factor it. Anytime you factor it, you always want the first term positive. Okay, that makes things easier. So what could I do here? It's going to change the sign of everything, but it's going to make this first one positive.
Take the negative 1.
Yeah, just take a negative 1 or factor a negative 1 out, multiply by a negative 1, however you think of it. So it's sine squared x minus sine x minus 3 equals 0. I just multiplied everything by negative 1. You want the squared term positive when you need to factor.
For the one above it, why is it negative sine squared x? The 1 is positive.
Because it's 2 times negative sine squared x, because of that minus right there. Okay. All right, now let's see if we can factor. Okay, so my first term here would be 2 sine x and sine x. Because if I multiplied those together, 2 sine x times sine x would be 2 sine squared x. Now I have a negative middle, negative constant. What do my signs have to be? Yep, I need a negative and positive, and do I want them in that order? Let's try the positive, negative. And 2 numbers that multiply to give me 3. 1 and 3. Okay, I'm going to put the 1 here and the 3 there. Yeah, let's check it and see, but we might have to switch something. This is going to give me negative 2 sine plus 3. Negative 2 plus 3 is a positive 1. So what do I need to flip? Flip my signs. Now I've got 2 sine times 1, that's 2 sine. Take away 3 sine, 2 take away 3, that's my negative 1. Perfect. So now we just factored it. Okay. If it confuses you to factor it, just think of factoring this. This is the exact same problem to factor.
So we don't really need the sign. We can just take it.
Well, we
can take it out to factor.
if it helps you visually to think of it, you can, but
Yeah, because eventually that's like a lot more.
yeah. So this would factor as 2x minus 3, x plus 1, where x is really sine x. Okay. All right, so now we have this factor times this factor, and it's equal to 0. Okay. What's the only way you can multiply two things together and get 0?
One of them is 0.
Yeah, if one of them, either this one or the other one, equals 0. Okay? One or the other has to equal 0. Now we'll just solve each equation, see what we get. Okay. What's the first thing I would do on the equation on the left?
Move 3.
Move the 3. So 2 sine x equals 3.
3 divided by 2 x.
Divide by 2. Okay. And now I need to get rid of sine. Oh, I'm sorry. Did I flip that fraction? It should be 3 over 2. 3 divided by 2. And now what would I do on each side?
Inverse.
I'd do the inverse sine. Okay? So take inverse sine, just like we did on last night's homework. And I get x equals the inverse sine of 3 halves. Now, what's 3 halves as a decimal? Cameron?
1.5.
1.5. So what this is asking you right here is where does the graph of sine hit 1.5? It doesn't. How come? How high does it go?
1.
It only goes as high as 1. So if you try to type this in, you're going to get an error. Okay? The graph of sine is never equal to 3 halves, okay? Because this is bigger than 1. So from this part of the problem, we get no solution. Okay? This is not possible. Now, we still have this other equation. Maybe we'll get an answer from that. Okay? But if you try to type this in, you're just going to get an error. Try it. See what you get. All right. Jamie, what would be my first step to solve this other equation? Yep. Subtract 1. And now from here, there's 2 ways you can do it. Either take the inverse sine of both sides, or picture the graph of sine and think about where it hits -1. Okay, I'm going to do it that way. Anybody tell me where I hit -1? At what angle?
270.
270. Yep. Now, let me just see if they want degrees or radians. Okay, I think they wanted radians because they mentioned 2 pi. Tommy, can you tell me what 270 is in radians? Good, 3 pi over 2. Is there any other place that this graph hits -1? No. Okay. So this time, we don't have to think about that chart, the ASTC diagram, because I'm looking at the picture and I can see there's only one place that it hits -1. Now, if it was a little higher, okay, something like that, then I could see, well, there's 2 places. But anytime it's 1 or -1, the graph just touches it and there's only one spot. So that's the only answer that we get for that problem, 3 pi over 2. Okay, any questions on that? Mm-hmm.
If it wasn't repeating, would it be like plus 2 pi?
If they wanted all solutions, you'd put plus 2 pi k. Yeah, but this time they said specifically not to do that. Okay, so we're not going to put 2 pi k on any answers today.
When you factored the other part of the problem, when you had -2 sine squared x plus sine x plus 3, and then you switched the negative sign from the 2 to 3 on the other side, how did you do that?
I just multiplied everything by -1.
Oh.
The only reason I did that is because when we factor, the way you're taught in Algebra 1 is the first term always has to be positive, and if it's not, it's going to mess up your signs. Okay, so that's why I did that.
Yeah, into that mix.
Yep. Any other questions on that? Yep.
There's no way to solve that in the calculus when you're trying to put in sine x into the calculator. I got 90. I don't know.
You got 90, or you got, if you put in -1, you probably got -90?
Yeah, I got negative.
Yeah, so what happened was you got, if I continue this back in the other direction, instead of getting this answer, you got the answer in the period before. So what you'd have to do, okay, if we're thinking about it in degrees, what's the period of sine? Not 180. 2 pi or 360. So if you want to get the answer in the next period, you would add 360. And that's how I got 3 pi over 2 or 270. All right. The reason you can't write -90 is because they said the answer had to be between 0 and 2 pi. Okay, so if you ever get an answer that's not, just add the period to it, and you'll get the next answer. Okay? All right, so it does take a little practice to get used to this. It's really a lot with just quadratics, but there's a little trig involved. So we'll try a few more. Okay, so this one says find all solutions in one period. Okay, so now we have to remember what the periods of these are. Okay, what's the period of cosine? Yep.
2 pi?
Good, 2 pi. Now, does anybody remember the period of sine squared? We had a chart that was like sine to an even or sine to an odd, and I told you what the period was. Pi, yes. Okay, if you don't remember that, you might want to look back at that chart. Okay, probably, you know, it's in chapter 6 or 7. Okay. What's the least common multiple of pi and 2 pi? 2 pi. Okay. Least common multiple has to be at least it can't be smaller than 2 pi. It has to be at least that big. Okay. So because the period of this is 2 pi, which you guys just help me figure out, we are going to find all solutions between 0 and 2 pi. Okay. It's not the only way we could do it. We can do any window we want between 0, as long as it's 2 pi units wide. I think this is the easiest one to do. Okay. All right. Anytime we solve a quadratic, what number do you always want it equal to on one side? 0. So let's bring everything to one side. So we get 2 sine squared x. I'm going to minus cosine x. And I'm going to minus 1. Any questions on that step? And now we're right back where we were with the very beginning of the last problem. Everything's on one side. It's equal to 0. The only thing is we've got 2 different trig functions. Okay. Which one do you think I want to get rid of?
Sine squared.
Yep, sine squared. Okay, we're going to get rid of sine squared. So I'm going to write 2. Okay, leave parentheses because you're going to fill in something there. And now we just have to look up what sine squared is. Okay. Based on this identity right there. Can someone tell me what sine squared would equal? 1 minus cosine squared. So that's what we're going to put in. It's going to be just like the last problem, except I don't think this one factors. So I'll show you how to do the quadratic formula. Okay, I'm going to distribute and combine like terms all at once. So I'm going to do -2 cosine squared x minus cosine x. 2 times 1 is 2. 2 take away 1, 1. Okay, so 2 times 1 is 2. Minus 1 is 1. Okay. Any question on this one? Actually, this one might factor, but even if it does, let's go through the quadratic formula because it's good to practice one with that as well. Okay, so to plug in the quadratic formula, you want to identify what A, B, and C are. Who can tell me what A is here? -2. Yeah. B? -1. It's invisible. If you want to put it in, you can. And C? +1. Now, if we get a nice answer with the quadratic formula, that means we could have factored it. Okay? So, it's just good to practice it this way. All right, so -b plus or minus the square root of b squared.
Wouldn't B be -1?
What's that?
Wouldn't be the -1?
Oh, thank you. Yes. That's important. B is -1. Right. Yep, so now that's positive. So we got -b plus or minus the square root of b squared. That's fine. Minus 4ac all over 2a. Minus a minus is going to become a plus. What's 4 times 2? 8 times 1? 8 and 8 plus 1?
9. 8 and 8. 9.
9. All right, so we get 1 plus or minus, what's the square root of 9? 3. So this would have factored because we got a nice answer. Okay, and I'm going to do both of those out. I'll do -1 plus 3 and -1 minus 3 divided by -4. Okay. Now, before I do that out, I just want to remember, what am I solving for here?
Oh, cosine.
I'm solving for cosine x. So I'm going to write cosine x equals, right? Tyler, what's 1 plus 3? 4. And what's 4 divided by -4? -1. Okay, so there's one answer. Cosine x equals -1. Or cosine x equals, Dalton, what's 1 minus 3?
-2.
And what's -2 divided by -4?
0.5.
Yep, 0.5 or 1/2. Now we'll solve each one and see what we get. For the one on the left, anytime it's equal to 1 or -1, always just use the graph. Okay, it's easier that way. Okay, where does the graph of cosine hit -1? And it's only one time that it hits it. At 90, it hits 0. 270, it's also 0. 180. And in radians, that would be pi. So that is one answer. Okay, and it's the only answer we get from this part of the equation. It hits -1 right here. This is pi over 2, pi, 3 pi over 2, 2 pi. Okay, now when it's equal to 1/2, that we got to use our calculator for and see what happens. Okay, Jill, how do I get rid of cosine?
The inverse.
It's okay. Jill, yeah, inverse cosine. So x is inverse cosine of 1/2. Okay, type that in and see what you got. Okay, I'm in degrees, that's fine. I'm going to do it in degrees. If I need to change it, I'll just change it. 60 degrees. Okay. Does anybody remember what 60 degrees is in radians?
I mean, pure.
No, it's going to have pi in it. Pi is 180. It's pi over 3. Okay. Now, here's where we have to think, is there a second answer? How many quadrants is cosine positive in? 2 quadrants. We just found 60 degrees. That's quadrant 1. Where's the other quadrant where cosine is positive? Quadrant 4. We need to find the quadrant 4 answer. What are the directions if you're in quadrant 4 and you have your reference angle? What do you do?
360.
360 minus. Yes. So in quadrant 4, it's 360 minus your reference angle. Okay? So if you want to think of it in degrees because it helps you, you can, but we've got to write our final answer in radians. So we had 60. What's 360 minus 60? 300, which I'm just going to help you guys out. If you convert to radians, it's 5 pi over 3. Because pi over 3 is 60. So if you put a 5 in front of it, it's 5 times 60, or 300. Okay, it's a little tricky, because you got to remember, not only you got to get that first answer, you got to remember to get that second answer. Okay? The only time the second answer happens is if you land in a quadrant. Okay? Pi is not in a quadrant. That's on an axis. That's why when you drew the graph, it only hit one time. 0, 90, 180. If you get any one of those answers, they're not in a quadrant. You don't have to worry about the second thing. If you get an answer like 60, that's right in the middle of a quadrant, then you got to go through this whole diagram. Okay.
Can you explain how you got 5 over 3?
You see how we got 300? So we took our reference angle, which is 60.
Yeah.
360 minus 60 is 300.
Yeah.
And then just going back to how you convert,
Yeah.
if you reduce this, 60 goes into this 3 times, 60 goes into 300 5 times. So 5 pi over 3.
Yeah.
After a while, when you use a lot of the common ones, you almost memorize them.
Just want to double check, how'd you get the pi over 3?
How do we get the pi over 3? That came from inverse cosine of a half. We did it in degrees, so we'd get a nice answer and we could see it. And then we changed, or somebody changed 60 degrees to radians for me.
Okay, so that's basically the same thing as the inverse cosine of that.
Yeah, inverse cosine of a half, it's 60, but I did degrees. Okay, this problem asked for radians, so. If you do everything in degrees, that's fine. Just remember to change it to radians at the end. I like degrees. I think it's easier to work with at first, and then I change it at the end. Yep.
So is the answer also pi?
Yes, everything I circled is an answer.
Okay.
Pi is the answer from the first equation, and the second equation had 2 answers. Sometimes the first equation won't give you any answer, like we had in the first problem. Sometimes the first equation will give you just 1 answer. Sometimes both equations give you 2 answers. Okay? Depends on the problem. Okay. Questions on that one? All right. Okay, this part, again, I don't write this down. You can just read it. It's what I've already said. Remember, if you can find one solution to a trig equation, there's another solution every period. So usually we put plus 2 pi k if we're finding complete solutions. Okay, we're not finding complete solutions. We're only finding solutions between 2 numbers. Okay. Any questions on that? I just don't want anybody to be confused why we're not putting plus 2 pi k. Okay. Just, we don't have to in this section. Okay, so again, do not find all solutions, just the ones between 0 and 2 pi. Okay, it says tangent x equals 3 cosine x. Does anybody remember the identity for tangent? There's a way you can rewrite tangent using sines and cosines. And that's what we want to do here. Close, very close, not cosine over sine. It's sine over cosine. Okay, so the first step, anytime I see something that's not a sine or cosine, I try to change it to a sine or cosine. And then work from there. Okay, and then how could I get rid of this cosine? Yeah, I'm going to multiply each side by cosine. So that's gone. And I get sine of x equals 3 cosine squared x. Now this is really just like
And then you can change
this problem. Yeah, now we're going to change this. Okay. I would bring everything to one side first, and then change it. So we have a choice: either bring everything to the right or bring everything to the left. You want to put everything on the left? Okay. So we'd have negative 3 cosine squared x plus sine x equals 0. And from here, there's nothing different about this problem than the last problem. You're going to use quadratic formula. This one actually does not factor. I know it, so you cannot factor this one. But first, any questions up to this step? All right. Cosine squared. Does anybody remember what that is? I think we already did it once. 1 minus sine squared. Okay, plus sine x. Right, we've got negative 3 times negative sine. What's negative times negative? Positive. Plus sine x. And negative 3 times 1. Page? Yeah, just negative 3 equals 0. Okay, now do we have a quadratic equation? Yes, we've got something squared, something, and then the constant. Okay, does anybody want me to keep going from here?
Yeah.
Okay, so quadratic equation now. Identify A, B, and C. Okay, I'm going to go through the quadratic formula really pretty quick. So negative b plus or minus square root of b squared 4ac over 2a minus a minus becomes a plus. 4 times 3 is 12, times 3 is 36, plus 1 is 37. Okay, so here are my two answers. And now, did I just solve for x? No, what did I solve for? I solved for what was right there, sine x. Okay, so now I'm going to separate it into two equations. I'm going to write this as a decimal. I'd like to know what that is. So all right, sine x equals, okay, and I'll do that out. Actually, I already have them. Okay. Oh, so we've got negative 1 plus the square root of 37. Okay, that's the top, and then divide by 6. 0.847. Or, now do the minus. Negative 1 minus square root 37. Divide by 6. Negative 1.180. First question, I want to just look at this. This is asking you when the graph of sine hits negative 1.1. That doesn't happen. Okay? There's no solution from that part. Sine never hits negative 1.1. So we don't have to worry about that one. Does sine hit 0.847? Yeah, and it'll hit it twice. Think of the graph. This is 1, 0.847 is somewhere in there. There's two answers. Okay. So to get the first one, how do we get rid of sine? Take the inverse sine. Okay, and we could do it in degrees or radians. Just did they specify? Okay, they said radians, so I'll switch to radians. Okay, and one answer we get is 1.01. Okay. Now, what other quadrant is sine equal to a positive number? Quadrant 2. So you just told me we're going to be in quadrant 2. What are the directions in quadrant 2 say to do?
180 minus. Yeah.
Okay, 180 minus the reference angle. What if we're working in radians?
Pi.
Pi. So quadrant 2. Pi minus my reference angle. What's my reference angle? I just found it. 1.01. So I'm going to take pi minus my reference angle. 2.13. And the book says 1.01 and 2.13. Yep. Okay, any questions on that one?
So how did you find both the x's? I'm still kind of confused. Like, I understand the graph part, there's possible times you need two solutions.
So the first x, you just do inverse sine of both sides.
Oh, okay.
And then the second x is, you look at your diagram. I'm looking for where sine is equal to a positive. That's quadrant 2. And the directions in quadrant 2 is to take your answer and minus it from pi. If you were doing it in degrees, you'd minus it from 180. If you're in quadrant 3, you're adding to 180. In quadrant 4, subtracting from 360. Okay, it takes a little practice to get used to them. Okay, this one is really the same as one. We've done a lot of these types, so I'm gonna skip over this one. All right, let's try this one. 3 tangent to the fourth x equals 1 plus secant squared. Okay, and I'll give you a hint. That's another identity we learned. Same time we learned sine squared plus cosine squared equals 1. Okay, so what do you think I'm going to replace here? That's about
What do
chi.
you mean by replace?
Well, something I got to replace because I got to have all the same trig function. So what?
Tangent.
Do I have a formula for tangent to the fourth though?
No.
No, but I do have a formula up here that has one of these terms in it, which,
Secant.
yeah, secant squared. We have a formula for that. Okay? Secant squared is 1 plus tangent squared. Okay? So plug that in, and we'll see what happens. 3 tangent to the fourth x. And on the other side, I have 1 plus tangent squared. What's 1 plus 1 give me? 2, so let's just do that. And this is 3 tangent to the 4th x. Let's bring everything to the left. Okay. Minus tangent squared. Okay. How would I bring the 2 over?
Negative.
Yep, negative 2 equals 0. Right, and is this a quadratic type equation? Do you have the same term everywhere? Yeah? Do you have a constant at the end? Is the first exponent double the second?
Yes.
Yes. Then this is a quadratic equation, and it does factor. So we're not going to use quadratic formula. Okay. What do you think my first term would be? Give you a hint.
3 tan squared.
Yep, 3 tan squared. My second term,
Tan squared.
tangent squared. What about my signs?
Minus.
What is it?
Plus minus.
Yeah, we're going to need a plus and a minus because you're going to multiply 2 numbers to get a negative. Okay, we'll try it in the order we said and see if it works. 2 numbers that multiply to give me 2. 1 and 2. Let's check. 3 tan squared times 1, that's negative 3 tan squared, plus 2, negative 3 plus 2, negative 1, that's perfect. All right, so either what's on the left equals 0, or what's on the right equals 0. Okay, watch what happens if you try to solve the one on the left. We're not going to have to worry about this one very long. What's the first thing you'd do to get tangent squared by itself? You'd subtract 2, and then what would you do?
Divide by 3.
Then you divide by 3. Now the next step would be to get rid of this square root, or this square. Okay? You would take a square root. It's the only way to get rid of an exponent of 2. But can you take the square root of a negative number? No. If this negative wasn't here, we'd be fine. But because it's there, there's no solution. Okay, this part is imaginary because of that negative symbol. Can't take the square root of a negative. So don't worry about the left. Okay, on this one, you bring the 1 to the other side. How do we get rid of this exponent? Take the square root. And what's the square root of 1? 1 or what else? Negative 1. Okay. Anytime you take a square root, remember square means 2. There's 2 answers. Okay. And how do I solve each of those? What am I going to do to get rid of tangent?
Inverse of tan.
Yeah. Take the inverse tangent. So do inverse tangent of 1. Let's do this in degrees. See if we get a nice answer. 45. Which is pi over 4. And inverse tangent of negative 1. Negative 45. Okay, I'm going to check and make sure that's what they said to be between. This time they said negatives were okay. Okay, that's negative 90 to positive 90. Both of these answers fit within that. Okay, any question on that one? All right, so let's finish up. That one's the same as that one. All right, let's do Let's do this one. Okay. Because this one kind of ties in with yesterday.
Is it a longer one or is it kind of short?
This one's pretty short.
Okay. Trying to figure out what.
Okay, what's the problem here? It's the same trig function, but what makes them different? One of them has a what in the argument? A 2. Does anybody remember my identity to get rid of that 2? Yeah? Yeah, it's a double angle identity. Right? What is sine 2x equal to? Good. 2 sine x cosine x. And now how would I bring this sine x to the other side? Yep. Make it negative, subtract it. And you're going to see something kind of like we did yesterday. What do these both have in common? Sine x. When two things have something in common, what can you do with it? You factor it. Factor it out. If I factor sine x out from the first term, what am I left with? 2 cosine x.
How do we get 2 cosine x?
Because if you factor out the sine, you're left with 2 cosine x. Just
Oh, okay.
cover up the
Oh,
sine.
okay.
Okay. What if you factor sine x out of the second term? Yep, you're left with a negative 1. And now we just set each factor equal to 0 and solve. Either the first factor equals 0 or the second one. Okay, first one, I'm going to think about the graph. Where does sine hit 0? At 0. Where else? 90, it hits 1. 180. Don't include this, that's a repeat. So we'll do 0 and pi. For cosine x, I'm going to add 1. And then divide by 2. And how do we get rid of cosine?
What about the negative sign?
That's where I added the 1. Yeah, so the negative goes away. Not reciprocal, but call it inverse. Inverse cosine of a half. I think we already did this earlier. You get 60. That's pi over 3. Does anybody remember the other answer? 5 pi over 3. Yeah. If you look earlier in your notes, we already did this one. Okay. Now the last thing, just make sure all the answers are within 0 to 2 pi. Okay. All of these answers between 0 and 2 pi? How about, is 0 between 0 and 2 pi? Yeah. Pi is. That's 60, that one is. And that's 300. They're all between 0 and 360. So all of these are.
What if somewhere?
If it wasn't, I'd cross it out. Just put a line through it. All right, so it does take a little bit of practice to get used to them, but we'll take some time tomorrow. Okay, go over the homework. And not every problem in the homework you're going to have to solve from scratch. Some I already factored for you, so you just have to continue from that point. The last 4 you're solving from scratch. Okay?